Well, hello everybody.
Hello.
My name is Camille.
And my name is Daan, and we are from the Netherlands, so actually pretty close to here. And well, we are here to participate in the Science Me competition, of course. And that's quite something memorable. So we actually want to start by taking a picture of all of us.
I want to take a picture of you, and I will use my super fancy camera. But it's a little dark in the audience, so maybe I will flash. And then I can see you. Dan, can you give me a flash, maybe?
Yeah, I'll make a flash, but just an ordinary flash is a bit boring, so I'm going to make a scientific flash. And in order to do so, I've taken a bomb with me, a bomb that's made of magnesium. And magnesium, you might know magnesium from the firework, and that's in this little bomb in here. So what I'm going to do is I'm going to light this, but this bomb will become about 3000 degrees Celsius. So I am going to do that very safely, of course. So I'm going to put my own glasses away and use these safety goggles. This is just an ordinary lighter. I'm gonna put this one on and lock it. Now I've got fire resistant gloves in here, so I'm gonna put these on.
And now you think I can make a flash out of this? I can take a picture?
You can take a picture, yeah?
I want to see that.
Okay, so what we're gonna do is to dim the stage lights a bit, so we can see the audience a bit better.
And here's my camera.
Yes. So I need to put on the glove. Now I'm going to take this lighter with this enormous thing so I won't be near the flash when it comes. Yes, that's it. And I'm gonna light it. Are you ready?
Yeah.
Okay, here we go.
That was a nice picture, I guess.
Kan je het vuur even uit doen? Vuur uit. De vloer.
Oh, waar?
Voor. Well, have you made a nice picture, Camille?
I think so, I hope it. It's a shame I cannot show it on the screen, but I think the picture is nice. I will send it to you on Facebook. And this is how they used to flash for a camera. My foot is still burning a bit. It's just the paper that's still burning. It's no... Does it work? Yeah. It's just the paper, so it's nothing dangerous. And this is how they used to take pictures. They used the magnesium to give a flash, and nowadays we have electric flashes. But that's how they used to do it in history. And what we're going to do now, we go from history to the future. We all hope, of course, that in the future we will have things like hoverboards, and we can fly. And actually, we brought something which you can fly on. You can stand on it, and you can hover above the ground. And it's over here. It's the human levitator. Let me get it. Now, can you explain a bit what happens in the human levitator?
Yeah, okay, so what happens in this human levitator is that this thing is actually made out of two parts. We have a superconductor, which is a really strange kind of thing. I don't know if you know anything about resistance. But resistance is something that makes charging our phone take a bit of time. When we charge our phones, we put it in the socket, and then we need to wait a few hours and then our phone is full. That is because there is some resistance. Well, if the resistance would be zero, then we would be able to charge our phone immediately. Well, in this thing, there is a superconductor. The superconductor is down here, and the resistance in the superconductor is zero. And that gives us all strange kinds of effects, including the fact that this magnet that's on top of it is able to float. Well, now the magnet is still on this wooden plate, but once we get the wood away, the magnet will float. So, the magnet is currently floating on top of a superconductor, and to show you that we're not lying, we've brought a rope. So what we're going to do is to pull the rope underneath the magnet, between the magnet and the superconductor. So, Camille?
Yes.
One part of the rope for you.
Thank you.
And one for me. And we can put it all the way through here without any problem. So there are no strings attached. It's not fake. And now, Camille, I want you to try to go stand on it and float.
I promise you that I can float, and I will demonstrate it here. I stand on the superconductor. I can turn around, get a bit dizzy. And it does really float. There's nothing between it. Can you still show the rope, maybe?
Yeah, of course. Here's the rope.
Thank you.
So I'll just... There it is.
And I'm still above it. Thank you.
Okay, so now I actually want to go on to something different. You've been seeing all this smoke around this human levitator. And this smoke, you've probably seen it before with the Belgian people and with the Finnish people, that is made from liquid nitrogen. Well, actually, it originates from liquid nitrogen. So what we're going to do is make this even bigger. We're going to make a lot more smoke. So I'm going to put some liquid nitrogen in this container until it has a nice layer of liquid nitrogen. And then what we're going to do is to add some boiling water. And boiling water is, of course, how hot is boiling water? How many degrees? 100. 100, yes, that's right. Liquid nitrogen is 200 degrees below zero, so that's a temperature difference of 300 degrees. So what we're going to do is make an enormous temperature difference, and that will hopefully cause a lot of clouds to form. So we're going to see and try and find out if Camille can do that.
I hope I can do it. And here I have the boiling water, you can see it's still boiling. So I'm putting it in, and I think it's nice if we all count down. So if you want to count down with me, 3, 2, 1. And that's what happens with liquid nitrogen. Thank you.
Okay, well, Camille, this is of course more clouds than we saw before, but I don't really like that we didn't see an explosion. I really want to see an explosion. Do you guys want to see an explosion? Yeah. Okay, so we're going to make an explosion. What we have here is for safety. I'm going to put it a little bit more backwards. Okay. So what we're going to do is take a Coke bottle, just an ordinary Coke bottle, and we're going to fill this one up with liquid nitrogen. Once I will put the screw on the bottle will close, and the liquid nitrogen can't go anywhere anymore, and the bottle will explode. That makes an awful lot of noise, so I'm going to ask you all to close your ears at the moment I say that. And just to repeat it in German.
Ja. Ohren zuhalten. Ohren zuhalten.
Okay, not yet, because we're not done, but as soon as I tell you to close your ears, please do so.
So,
okay.
This is a box with fun in it. It's ping pong balls.
Okay, so we're going to protect ourselves as well, of course. We're going to use ear protectors for us, but we couldn't bring 100 ear protectors, so you're going to have to use your own hands. I'm also going to wear a glove for more safety.
Sorry, Dan, what are you saying? I can hear you.
What?
What?
Okay, we're gonna start. I have no idea what Camille just said, but let's do it.
So I hope it's full enough.
No, not yet.
Not yet. More nitrogen.
Yeah, just use the jeweler.
Yeah, it's fun.
We're going to use a lot of nitrogen to make the explosion as loud as possible.
Even more nitrogen. There's no such thing as too much nitrogen. It's an almost empty jar. This should be fine, Dad.
No, more. Take one from there.
So who wants more nitrogen? I can't hear you. I literally cannot hear you.
I think they were cheering really loud.
Oh. It's too much nitrogen.
There's no such thing as too much nitrogen, Camille. Okay, yeah, that's fine, that's fine. Okay, you ready?
I'm ready.
Okay, I'm going to put this on right now, and now I want you to close your ears right now. Just keep your ears closed. It might explode after a while. It will explode after a while. It might take some more time. That's correct. That happens all the time. Well, was that a nice explosion?
Thank you.
Thank you so much. It was our show. Thank you for your attention.